So this is our lesson on polynomial operations. So we want to make sure that we remember what a polynomial is, and then we are going to add, subtract, and multiply them. So first of all, polynomial. Poly is the prefix that means many or lots of, and nomial is the root word that means number in Greek, but more specifically to what we're talking about, it's terms. So a polynomial is just many terms. Now we have a few specific types of polynomials. Oh, wait a second. Let's go back and make sure that we remember what is a term. Now I stated this in Canvas, but just as a review, a term is a number of variable or a product of a number and variables separated by addition. Okay? So if I had 3x, that means 3 times x, so that's one term. Okay, if I had x plus 2, those are two terms because x is a term and 2 is a term. If I have 4x minus 5, that's also two terms. 4 times x is a term, and then the other term is a negative 5 because subtraction is really adding the opposite. So even though a term is separated by addition, you have to remember that subtraction just means that that term is negative. So my two terms there would be 4x and negative 5 are the two terms of that binomial. Now that brings me back to the fact that, okay, polynomials are many terms. We do have a few types of terms or a few types of polynomials that we use on a regular basis. A monomial has the prefix mono in front of nomial. Now because the prefix mono ends in the no, which is the same as the root word nomial, we only write it once. We don't say mononomial. That's a little bit. Mononomial or a monomial means that we only have one term. So this 3x over here is an example of a monomial. After a monomial, we have a binomial. I like to ride my bicycle. Bi meaning two, so a binomial means that you have two terms. X plus 2 is an example of a binomial. 4x minus 5 is an example of a binomial. And then above that, before we learned how to ride our bicycle, we learned how to ride our tricycle. So a trinomial has 3 terms. So that would be like x squared minus 5x plus 7. That's an example of a trinomial because we'd have x squared as a term, we'd have negative 5x as a term, then we have the plus sign, and we have our other term, which is 7. So those are the 3 terms in that case. So that's some of the terminology of what is a polynomial. Now, a polynomial, like I said, many terms together. If we go back to that last example there and we look at that x squared minus 5x plus 7, we have to realize that this is 3 different terms. Now, terms can only be added to other like terms. So we can only add what's called like terms. Like terms are terms that are alike. No, that's a terrible definition. Like terms have the same variables, and the variables have the same exponents. So there's 2 parts to it. So I cannot combine an x squared with an x because the exponent on the x squared is this 2, and the exponent on the x, if there's no exponent up there, it's always a 1. 1 is the god of mathland. 1 is the god of mathland. He, she, it is always with us, whether we see him, her, it, or not. So if there is no number there and we're not sure, most likely it's 1. So there is the 1 sitting on your shoulder, x's shoulder, and it's different than the exponent on the x squared. So those are not like terms, so I cannot combine them. The 7 at the end does not have an x. So that's not like the other ones either, because the other ones have a variable and that one does not. So these three terms are not like terms. And that's why that would be as simplified as you could go with that problem. We can't do anything else with it because we can't combine things that are not alike. See, I call these choo-choo trains. So in each car is its own type of train car. You know, we have, woo, I'm not an artist. So maybe the x squared is our locomotive, and maybe the x is a boxcar, and the last one that only has the constant, a number without a variable, is called a constant. Maybe that's my caboose. My constant is the caboose. So you don't put things that belong in the boxcar in with the caboose or in the locomotive. They're all separate types of train cars, and they're specific to a certain type of cargo. So the variable and the exponent is kind of like the label of what kind of train car you have. Now, train cars can't go anywhere unless they're coupled together. The couplers on the terms or the train cars are your plus or your minus signs. That separates the terms, it separates the different train cars, and yet keeps it connected to the car before it or the car after it, so it can continue down the track as one entity. So that's what we have when we're dealing with polynomials. Okay? It's okay when you are adding and subtracting and multiplying to have more than one term as your answer. It does not have to come to one single answer. That's the difference between arithmetic and algebra. Is in algebra, we don't always have one pretty answer at the end. Okay? So let's go through and add some polynomials. So we have this problem. Now, how do I know what I'm doing in this problem? Well, the parentheses are there to group a polynomial together. So my first polynomial is 4x squared minus 5x plus 6. My second polynomial is the 3x squared minus 2x minus 9. What I'm doing with those two different polynomials is indicated by the symbol in between. In this case, there's a plus sign. So I'm adding the two polynomials. When I'm adding polynomials, I'm going to add my like terms. Now, our standard form is how we should put all of our answers. Standard form means that the term that has the highest exponent goes first, and then in decreasing order. So this problem is nicely set up in which actually each of our polynomials was already in standard form. So it's going to be a little bit easier to find those like terms and to put them in the same order. So I like to, when I'm going through this, either use different colors, or if I don't have different colors available to me, I use different lines to make sure that I don't miss any of my terms and that I combine all of them. Okay, so I'm looking for x squares because the first thing I do is I kind of glance through for all the exponents, and the highest one is that 2. So I look for all of my x squareds. Here I have an x squared, here I have an x squared. Because the exponent is a 2, I like to put 2 lines underneath it so that I know what is matching up. Now, I recognize that those are like terms because they have the same variable to the same exponent. So in order to combine those, I just add the numbers in front. The numbers in front are called coefficients. So we just add the coefficients. So 4 plus 3 is 7. Now, if I was making sure that I'm adding things that are alike, the part that makes them alike stays like that when I combine them. So 4x squared plus 3x squared is going to give me 7x squared. That part does not change. Now I look for my x terms. Here is a negative 5x. Remember, the sign in front goes with it. If you need to do change to all of your subtractions until you get more comfortable with negatives, do so. What's change? Change all of your subtractions to adding the opposite. There's always 2 changes to make something equivalent but look different. So over here I have another negative 2x, so it's adding the opposite. So now I'm combining a negative 5x and a negative 2x. So really it's negative 5x plus negative 2x. A negative plus a negative is more negative. If I wrote a check for $5 and I wrote a check for $2, I'm further in the hole. Or if I have a 5-foot hole and I dig 2 feet more, I'm further in the hole. So it's negative 7x. Now to indicate that it's negative, we just use a minus sign. You use one or the other. You either use the negative as a minus sign, or we could have written it as plus a negative. But only one of those positions will be the negative, because if you make two of them, two negatives make a positive when they're next to each other like that. Okay. Continuing on, then we have a positive 6 and a negative 9. So 6 plus a negative 9, the 6 is positive, the 9 is negative that we are adding together. When I add opposite signs, I subtract them and keep the sign of the larger number. Now the larger number is really the number that's further from 0. So we get to say, okay, it's a positive 6, it's a negative 9. I see that they're one of each. Now I kind of ignore that and say, okay, I know I'm going to subtract. If I was given the numbers 6 and 9 back in first, second grade when I was learning how to subtract, how would they tell me to subtract? They would have told me to put the 9 first because that's the bigger number, and then take 6 away from it. So that's the order that I'm going to do that subtraction. 9 minus 6 gives me 3. But the number I start with had the negative. So my answer is negative. Because essentially I couldn't get out of the negative land. This is essentially saying I have $6 in my account and I wrote a check for $9. Well, 6 of it was covered, but 3 of it was not. So I'm in the hole $3. So I have negative 3. Now this is as far as I can go. Even though those first two terms both have a 7, the variable and the exponents are not the same, so I cannot combine them further. It's acceptable to leave that middle term as plus a negative. I'm hoping that as you get more comfortable with the arithmetic as we move forward, you'll be able to write this as always just using subtraction signs. But it's perfectly okay if you had plus a negative instead. And that's how you're going to add polynomials. So how is it different if I'm subtracting? The key to remember, these are the same polynomials, but instead of adding them, we are subtracting them because that's the symbol that's in between my parentheses. So how is it going to be different if I'm subtracting? The key that we need to remember is that we are subtracting everything in that second trinomial, the 3x squared minus 2x minus 9. Not just the first term. So we have the tendency to forget to do that. And so this is the trick or the little procedure that they like to do to help us make fewer mistakes. Remember what I stated before. Subtraction is really the same thing as adding the opposite. So if I do take that into consideration, what I can do is change that subtraction symbol that's in between there into adding the opposite. Now remember that subtraction sign was between the parentheses, so all of my symbols still have to be changed between my parentheses. So what does that negative out front mean? Well, again, that is the god of mathland. That's really a -1. That needs to be multiplied because remember, a number in front of parentheses means multiplication, and we would have to do multiplication before we can do any addition or subtraction according to our order of operations. It's all based on that order of operations. Remember, our order of operations is please excuse my dear Aunt Sally, also known as PEMDAS. Your parentheses, your exponents, multiplication and division together left to right, addition and subtraction together left to right. I can't do any of this adding and subtracting until I take care of multiplying. So my next step here is to use what's called the distributive property. When you have a number outside of parentheses, that number gets distributed or multiplied to every term inside the parentheses. Now, nothing happened to this first one, so I'm going to keep writing this first trinomial as it was. And now I'm going to distribute through that -1. So -1 times the positive 3x squared, multiplying a mismatch of signs is bad. That's bad. That's really, really bad, meaning that you're going to get a negative or a bad result. A -1 times, remember this is a -2x because the sign in front goes with, a negative times a negative. When multiplying matching signs, that's good, that's good, that's really, really good. That's a positive, so that's going to give me positive 2x. -1 times that -9, again, positive 9. So you'll notice that all that happened when I multiplied through by that -1 is that the signs changed. Anything that was a positive became a negative. Anything that was a negative became a positive. Now, do I really need the parentheses in that first polynomial? Well, now that these are all just terms together, I don't care what's my first polynomial and what's my second polynomial, because I'm going to be adding like terms. When adding, you don't need parentheses. And there's nothing going on with this first. So the only reason that those parentheses were there was to once again say, this is my first polynomial, and this is my second polynomial, and I'm doing something to it. We had to do something, you had to use that distributive property in order to get rid of the parentheses in the second polynomial, because that meant something because there was a minus sign in front of it. Okay. So now that we have all of our terms, we can combine those like terms. So again, just like we did before, my highest exponent is the square, so I have 4x squared, but here it's a -3x squared. So 4x squared minus 3x squared, if you prefer, is 1x squared. Now you can write 1x squared, but really that 1 isn't necessary because 1 times anything is anything. And so 1 times x squared just gives us x squared. But we'll keep it there for right now. -5x and a positive 2x. If I have a 5-foot hole and I add 2 feet of dirt, I'm still in the hole, but it's not as deep. Now it's only in the hole 3 feet deep. Again, the 5 is negative, the 2 is positive. I have one of each sign, so I'm going to subtract them. I would have subtracted them as 5 minus 2, and the number I started with was the negative, so my result will be negative. And then we have a positive 6, and now it's a positive 9, which is going to make it a positive, so I need that plus sign to separate that term from the others, 15. And again, I don't have to have that 1 in front of the x squared. I could simply write this as x squared minus 3x plus 15. Now, you won't be downgraded if you left that 1 there. Again, if that's what makes you comfortable at this point, leave it there. I'm okay with that. But as you move forward, you might start recognizing that the 1 isn't necessary, and it's a little bit a cleaner look not to write it in there. Now to do some multiplying of polynomials. In this case, I have just a monomial, -6x, times a trinomial, 8x squared minus 3x plus 9. To simplify this, we just have the one number on the outside. This is just an extension of our distributive property. The distributive property simply states that if you have a number on the outside of parentheses times a quantity inside, the number on the outside gets multiplied in. So a times the quantity of b plus c would equal a times b plus a times c. Now this can get expanded for more than just 2 terms inside. It doesn't have to be just a b plus c. It could be b plus c minus d minus e minus f plus g. It works the same way. The number on the outside gets distributed or multiplied inside. So if I was showing all of the steps here, it's going to be a -6x times 8x squared minus -6x times 3x plus -6x times 9. Okay. Now, ideally, when you are working through this yourself, after you've practiced a few of these, you shouldn't have to write out that entire step. You should be able to just do the math. But right now, if you're not so certain about things, show more work. If you're uncertain, doing more work is more beneficial than doing less. So now we multiply. Negative times a positive is going to give me negative 48. Now here's where our exponent laws come into play. I have x to the first times x squared. When multiplying like base numbers, we add the exponents. So an x times an x squared would give me x cubed. In the next one, we have a negative times a negative. Two negatives in a row go change, change. So subtracting a negative is the same thing as adding the opposite. The opposite of a negative is a positive. So this is just adding. 6 times 3 is 18. X times x, remember those exponents of 1. 1 plus 1 is 2. And then in our third term, we have, once again, a negative times a positive, so that's going to give me a negative. 6 times 9. Now remember, when you're multiplying by 9, the numbers always add up to 9. So this is a way for you to remember 6 times 9 is 54, because 5 plus 4 is 9, and not 56. And the x, don't forget that bad boy. In addition, just as a little side note, in addition also it's 56, or 5 sixes, 7 times 8. So that one kind of flows together. 56 is 7 times 8. The 6 times 9 is 54, because they have to add to 9. Okay? And that's all you have to do for this particular problem. So when you have a binomial times a binomial, or two terms times two terms, we oftentimes use what's called the FOIL method. Now FOIL is just a mnemonic device to help us remember what we're doing. So remember, these are binomials, so there's two terms. There's a first term and a last term. 2x is the first term, 3 is the last term of the first binomial, x is the first term, and negative 5 is the last term of the second binomial. So in the mnemonic device of FOIL, F stands for your first terms. So your first terms is taking 2x times x. Then you're going to add to that, the O stands for your outside terms. The outside terms are on the out edges, so that's the 2x and the negative 5. The I stands for your inside terms. So if 2x and negative 5 are the outside terms, then 3 and x would be the inside terms. And then finally, we have L for your last terms. Well, if 2x and x were the first terms, 3 and negative 5 are the last terms. So that's what's actually going to get multiplied together. And so now you can just do that math. Again, it's nice in the first few to set it up so that you see where all of your numbers come from. And then eventually you should be able to do this without showing all of this extra steps and go straight into it. Now you'll notice that when you do your multiplying, that the inside terms, the OI of FOIL, are like terms. With these being like terms, you can combine those, and your final answer will be 2x squared, negative 10x plus 3x is going to give me negative 7x minus 15. So when you take a binomial times a binomial, oftentimes your result will be a trinomial. You want to do a lot of multiplying of a binomial times a binomial, because the next lesson on factoring is working it backwards. Factoring is going to start with something like this trinomial and write it as a product of two binomials. Now, before we move on, there is another technique. If you're not overly comfortable with that FOIL method, I do have another way that we can multiply binomials. The other way of multiplying binomials is using the box method. So you just make a box. So this is only a 2 by 2 because we have 2 terms in the first parentheses and 2 terms in the second parentheses. And then 1 term goes by each box. So if you want to do the first one here on top, we have 2x and a positive 3. And on the side, I have an x and a negative 5. Again, it doesn't matter what you put across the top and what you put on the bottom. And then we do our multiplying. So anything to find this first square, it's a combination of the column, which is 2x, and this row, which is x. And you just multiply those two together. So 2x times x is 2x squared. Then you move across, and we have an x times this 3, which is going to give me 3x. Then now I'm in the second row, so I'm taking that first column, which is the 2x, times that negative 5 to get me negative 10x. And then negative 5 times a positive 3 is negative 15. Again, you're now going to write it all out because this is essentially doing your work off on the side. And then you're going to combine all of your like terms. And in the diagonal here is those like terms. And write out your final answer in standard form. So we start off with the squared term. Then the middle term, negative 10x and 3x is that negative 7x. And then negative 15. And you get the same answer. This is a really nice technique because I will be doing a video for the factoring portion, which uses essentially this same box but backwards. I'll have the items in the inside and then you'll be writing the numbers on the outside. So that's another form is the box method for multiplying polynomials. Now, the mnemonic device of FOIL is really nice if you have a binomial times a binomial, but the key is to be able to recognize that all you are doing is making sure that you are taking each term in your first set of parentheses and multiplying it to every term in your second set of parentheses. If you look back, it was the 2x that gets taken times the x and then times the negative 5. Then it was the 3 times the x times the negative 5. So it's the same thing goes if you don't have a binomial times a binomial. Here we have a binomial times a trinomial. And it's going to be the exact same idea that each term in the first gets multiplied or distributed to everything in the second. So we can take the 3x and multiply it through. So that's going to give me 21x cubed minus 6x squared plus 18x. Now I'm going to distribute through the 1. Now I like to write these vertically as opposed to horizontally. And now I'm just going to multiply the 1 all the way through. 1 times 7x squared is going to give me 7x squared. I'm going to put that underneath. That's a positive 7x squared underneath the other squared term. So I'm lining up my like terms. Then it's going to be a minus 2x and plus 6. Now I have all my like terms right underneath each other. It makes it much easier for me to add. So I'm going to have 21x cubed plus x squared, because it's a 1x squared, plus 16x plus 6. Again, we could set this up with the box as well. We can have 3x and a 1 on this side. And then 7x squared, negative 2x, 6 over here. And fill in blanks. Squared, negative 2x, 6. And combine your like terms. 21x cubed. Now here it's going to be 2 sets of like ones. Here's that positive x squared. Here's the positive 16x and the plus 6 at the end. So there are 2 different techniques of solving or of multiplying polynomials that'll work through it. Okay? Hopefully this helps you with your polynomials, and we'll see you on the next video.